Dear students, this is Dr. Moga, and today we'll be solving paper 6 from October-November 24, question 1. A student investigates the period of a pendulum. Figure 1.1 shows the setup. As you can see, this is the setup. Here's the bob, the X, bench, floor. The student adjusts the length of the pendulum so this means that the length of the pendulum can be adjusted until the distance d measured from the bottom of the support to the center of the bob is 90. So measured from the bottom of the support, which is here, to the bob is 90. So they adjusted the length. Initially, d was 90. He displaces the bob slightly and releases it so that it swings. He measures and records in table 1.1 the time t for 10 complete oscillations. So t here is for 10 complete oscillations. Calculate and record in table 1.1 the period t of the pendulum. What does the capital T represent? The period is the time for one oscillation. Oh, that makes sense. Okay. And then calculate a value for t squared. So initially, at 90 centimeters, it gave him 19.1 for 10 oscillations. So my answer is going to be by dividing by 10 for one oscillation, dividing by 10 for one oscillation. So for the first one, I'm going to get 1.91. And if I square that, it's going to be 3.65. I'm using three significant figures, just like they used in T. And for the second one, it's 13.5. And what I need to do is I need to repeat the same steps. So 13.5 is going to be 1.35. And we need to square that. So let me just do it on my calculator. 1.35 squared. It's going to give me 1.82. Okay. Next, we're going to have the student repeats the procedure using distance d45. Calculate and record. We've already done that. So then we have complete the column headings in table 1.1. Well, the small t was just time. It was 10 oscillations, but it was just time. So t will be in seconds. And capital T is for one oscillation, but it's just in seconds. Now when we squared it, it became second squared. Perfect. The last part, explain why timing 10 oscillations gives a more accurate result for the period t than timing one oscillation. This one's easy. When we're timing only one oscillation, of course we get lots of errors because we have different reaction times. So we can get timing errors due to reaction time okay. For period t, then timing one. Okay. Time errors due to reaction time. Okay. Will be or is less significant when we do it over a lot of oscillations. When spread over a longer time. Okay, perfect. Now describe one technique that you use to improve accuracy when measuring distance d. If you've watched the previous video, you would know how to do that. We already agreed that we can use a set square, which is like a triangular ruler. So we're going to say use a set square. Okay. If you want, you can say, I'm going to use a meter rule, but I'm going to put it close to the bob or the pendulum. So you can use this, or you can say that you're going to use a ruler or a meter rule close to the bob or the pendulum. Describe one technique that you use to improve accuracy when measuring the time t for 10 oscillations. This one is easy. Some students would like to write that they're going to use a fiducial point and counting when the pendulum passes the vertical, or they will start counting from 0. So my technique that I'd prefer with my students to improve accuracy when measuring the time t for 10 oscillations is that we will use a fiducial point to know when pendulum passes it, to start counting from 0. Okay. Part G. The pendulum support is 40 centimeters above the bench. Estimate the distance x between the bottom of the pendulum support and the floor. Estimate doesn't mean that, it means that you will not have a perfect answer. We're not all going to have the same answer. So they're saying that they changed it now, and now it's not 90 anymore, it's 40. So if I'm assuming that this is 40, then the lower part is a little bit bigger than that. So it's going to be almost 100, 120 maybe. So I'm going to write 120 centimeters. Any answer between 100 and 140 is correct. A student plans to plot a graph of t squared against d. Suggest suitable values of d that the student can use to obtain measurements that are sufficient for this task. Well, if I go back to this table, I only have 2 values. So if I want to get a more precise answer, I think we should use more values. So use 3 additional values. This question is for 2 marks. So I need to add 1 more. And I have to make sure as long as no value is greater than x, or distance x. What is distance x? If you look here, this is distance x. So if I use a length that is longer than distance x, then basically the pendulum will be doing nothing but dragging on the floor, right? So you have to be realistic. You should not use anything that is more than x. That's it for today. See you in the next class.